This is the lecture notes for lesson AmU5L2, and we're going to talk about the arc length and the area of sectors. All right, first of all, up at the top of your guided notes, let's look where it says arc length. We're going to look at a formula. Now, if theta is the central angle, so if you have a circle, the angle is going to be symbolized with the little theta symbol, and your radius naturally is r. Well, the arc length, the length of the arc that is formed by angle theta, is going to be represented with S. And we have a formula that says if you want to find out exactly what that is, you can use the formula S is equal to R times theta. So R is your radius. You can multiply R times theta, which is your degree, your angle, and get S. The only catch is that theta must be in radians. So if it's given to you as 120 degrees, the first thing you're going to have to do is use the formula that we used in section 1 to change that to radians. All right, let's just look at number 1. We have, and you're going to need a calculator, so if you don't have one, you might want to grab one. Now, I have already done the calculations, so I'm going to be able to go through this rather quickly. If it's going too fast, then press the pause button and you can try it on your calculator to be sure you're getting the right answers. Okay, so first of all, here is my theta and here's my radius. Now, how do you tell if theta is already in radians? Well, if it does not have the little degree symbol, and I'll write that, no degree means it's already in radians, so you don't have to change it. So in this one, my measurement is my angle measure. This is the angle measure, and it's already in radians. So in order to apply the formula, all I'm going to have to do is multiply 3 times 5 pi over 6. Now, let's just look at the math here. What's this going to do? Remember, this is like 3 over 1. So 6 and 3 reduce down. You've got 2. So you're going to have 5 pi over 2. Now, this is in feet. So what we want to do next is change this to a decimal. So you're going to put in your calculator 5 pi divided by 2, and it's going to give you the answer in pi. So you have to click that little button, the one that looks like the triangles back and forth, that gets you an approximation, and that is going to get you 7.9 feet. Okay, and we're only going to go out to tenths on our final answer on these. Okay. Okay, here's number 2. We're given pi over 4 for our angle, our intercepted angle, and this is already in radians. The way I know it's in radians is the first tip off is that there's a pi. That usually means it's in radians, but not always. But the deciding factor is that there is no degree symbol. So if there's no degree, it's in radians. According to our formula, now we're going to multiply the radius, which is 14.5 times pi over 4. Now this can get a little bit confusing, so I'm going to work through this one. When you multiply with that decimal on the top, you're going to get 14.5 pi over 4. Now you don't want a decimal in the top. If you put this in your calculator, it will go ahead and simplify it for you. But this is what the calculator is doing. It is changing this top. It's multiplying by 10 over 10. Why? To move that decimal over one place. So now you have 145 pi over 40. And then if you reduce that down, you're going to get 29 pi over 8. And if you hit the little button with the 2 triangles to turn it into a decimal, that's going to give you 11.4 inches. So this is going to be the process that the calculator is doing anytime you have a decimal in your numerator. But like I said, I showed you this time. So from now on, I'm just going to go straight to the simplified version. Okay? Okay, so number 3, we're given an intercepted arc of 3 pi over 2 and a radius of 0.5, and we want to find the arc length. So, if I were sketching this out for you, I want you to understand, this is telling you that there is an angle that instead of a degree measure, they're giving it to you in radians. So it's 3 pi over 2, and your radius is 0.5. We want to find the length of this arc, okay? So 3 pi over 2, to use our formula, we're going to have the radius, which is 0.5, times 3 pi over 2. Now when I multiply 0.5 times 3 pi, what is that going to give me? 1.5 pi over 2. All right, I need to simplify this down. So first you got to get rid of the decimal. Like I did in the other one, if you multiply by 10 over 10, you get 15 pi over 20, which reduces down to 3 pi over 4. I messed that all up, okay? Then when you hit the button on your calculator to change that to a decimal, the little, and I think I drew those arrows backwards, but you get the idea, that will reduce to 2.4 yards, okay? Okay, number 4, the intercepted angle is 2 pi, and the radius is 6.2, so we're going to use our formula. Fortunately, this is in radians again because there's no degree symbol, so I'm going to have 6.2 times 2 pi, and when I multiply those together, I'm going to get 12.4 pi, and if you put that in your calculator, that will give you 39 yards. Okay, for number 5, we have a 15-degree angle and we have a radius of 8.4. Now, this is in degrees, so we're going to have to do a step before we can put it in the formula. I've got to convert this to radians. So do you remember how to do that? You multiply your degree measure by what? Since you're going 2 radians, radians is on top, or the pi is on top. So when you multiply 15 times pi over 180, that's going to simplify down to pi over 12. So now this is 15 degrees in radian form. Now I'm going to be able to use my formula. S is equal to the radius, which is 8.4, times this in radians, which is pi over 12. Okay, and just like with the other one, you can put this in your calculator to simplify. You are going to have to change, when you multiply, you're going to get 8.4 pi over 12. So you would multiply by 10 over 10 if you're trying to do this by hand, and that's going to give you 84 pi is equal to 120. When you simplify that down, that's going to give you 7 pi over 10 meters, and that will round off to 2.2 meters. And they asked for the answer in both formats, so we're going to do both. So for number 6, we have a 330-degree angle, and the circle has a 10.5 millimeter radius, and we want to find the length of the intercepted arc. So, since this is degrees, the first thing you're going to have to do is change it to radians. So we're going to multiply by pi over 180, and that will reduce down to 11 pi over 6. All right. So now we're ready for the formula. S is equal to the radius, which is 10.5, times what we just found the degree measure to be in radians. So that's going to be 11 pi over 6. Okay, and I think I've done enough of them out by hand. You know, you've got to change that decimal once you multiply. Once you get this all in simplified form, you're going to have 77 pi over 4 millimeters. And then when you hit your rounding off button, your estimation button, that's going to change it to a decimal of 60.5 millimeters. Okay, for number 7, we have a 120-degree angle. We have a radius of 1.8, so the first thing I need to do is change this to radians. So I'm going to have 120 degrees times pi over 180, and this reduces down to give you 2 pi over 3. Now we're just going to fill into the formula. If S is equal to the radius, which is 1.8, times the degree measure in radians, which is 2 pi over 3. Let me make that a fraction. 2 pi over 3. All right, when you multiply that, that is going to give you 6 pi over 5, and we need to label it in feet. Then when you hit the approximation button to change it to a decimal, that's going to tell you 3.8 feet. Okay, number 9 is a word problem, and we're told there's a central angle theta in a circle with radius of 6 meters, and it has an intercepted arc length of 10 meters. Well, S is your arc length, okay? And we want to find the measure of theta in radians and in degrees. So in this case, we know this and we know this. What we're looking for is theta. So it's a little bit different. We're still going to use this formula though. So the way we're going to do it, S is 10. So I'm going to fill in 10 equals. I know what this is. And theta is my variable. Theta is what I'm trying to solve for. So just like solving an equation, the first thing you're going to do is divide both sides by 6. So now you have theta is equal to 5/3. Reduces down. So that is it in radians. Now, how do you change it to degrees? Well, we've had a lot of practice with this. So we're going to do 5/3. Remember, if you're going 2 degrees, degrees go on top. So this time we're going to have 180 degrees over pi, and doing the math on that is going to get you 95.5 degrees. Okay, for number 10, we have another scenario, and there's a merry-go-round that's going round and round and round and round. And in one ride, the rider goes 2,808 degrees. So that's a whole lot of 360-degree trips. All right, the rider is sitting 8 feet from the center of the circle. So we want to find out how far does the rider go in all these trips. So the first thing we want to do, and that's arc length. It's multiples of arcs, but that's the arc length. So how do we find that out? Well, we're going to use our formula. S is equal to R theta. All right, first I need to change degrees to radians. So I'm going to take 2808, and I'm going to multiply that times, if you're going 2 radians, the pi goes on top. Oops. Okay, now when you multiply that, when you do the math, that's going to get you 78 pi over 5. All right, and that was just put into the calculator. So now we're going to take S equals, your radius is 8, and we're going to multiply that times 78 pi over 5. And our first answer is going to be 392.1. And that's all you have to do on that one. Okay, in number 11, the situation is that Cincinnati is located at 39.1 degrees north. Atlanta is at 33.7 degrees north, and the radius of the Earth is 3960. So we want to find out how far apart these cities are. Well, since these are given in degrees, we can find the distance between them by subtracting. So if I subtract 39.1 minus 33.7, that's going to give me 5.4 degrees. Okay, I already have my radius, but this is in degrees, so the first thing I'm going to do is change 5.4 degrees to radians. So I'm going to multiply that by pi over 180. Multiplication and simplification will get me 3 pi over 100. Okay, so this is the first part, or this is a theta in my formula. So to plug it in, you're just going to put the radius, which is 3960, times the theta, which we said was 3 pi over 100. And using your handy dandy calculator to multiply those two things together and then reduce is going to get you a decimal form of 373.2, we're rounding off, miles. Okay? Okay, our next section is about the area of the sector. So this is the situation we're going to have an angle measure, that's theta. You have r, and instead of looking for the length of the arc, now we want to find the area of the sector, and this is going to be reduced to just a formula. That area is equal to 1/2 times theta, and once again that theta has to be in radians, or if you find that, what you find is going to be in radians, so you would convert it one way or the other, times r squared. There's our formula. So let's grab a problem and see what that's going to look like. Okay, so here's number 12, and our figure tells us that the angle theta here is 74 degrees and the radius is 4 centimeters. Okay, before we can do anything with this, we're going to have to change it to radians, so let's go ahead and multiply 74 times pi over 180, and that's going to reduce down to 37 pi over 90. Now we're just ready to fill in. So our area is going to be 1/2 times the degree in radians, which we just found to be 37 pi over 90, times r to the second power. Our r is 4, so now you have 4 squared. Okay, now the math is not all that complicated because you have a calculator. But when you multiply 1/2 times this, that's going to give you 37 pi over 180 times 4 squared is going to be 16. And then continuing to multiply and reduce, you're going to come up with a final answer of 10.3 centimeters squared. Now, how do you know whether to put your units in plain centimeters or squared centimeters? Well, it depends on what you're looking for. Anytime you are looking for area, your unit is in square units. It's not something you do. It's not something you have done. It's just if you found area, then that unit is squared. If you found length, that unit is not squared. Okay, let's look at number 13 now. We have an angle of 205 degrees and we have a radius of 11.2, and we want to find the area of the shaded region. So the first thing I have to do is convert the degree measure to radians. So I'm going to multiply that times pi over 180. Okay, doing the math on that is going to get you 41 pi over 36. All right, now for our formula, and I erased that, area is equal to 1/2 theta r squared. This is going to be area is equal to 1/2 times theta is now 41 pi over 36 times my radius squared, which is 11.2 squared. Okay, when you do all the math on that, you're going to have 41 pi over 36. If you just go ahead and multiply 1/2 times 11.2 squared, that's going to get you 125.44. It doesn't matter. Remember, when you've got three things multiplied together, it doesn't matter which two you do first. So do the two you want to. In this case, I just thought it'd be easier to go ahead and make this a number, so it took care of those two. All right, and then once again, putting that into the calculator and simplifying will give you 224.4 feet squared. Okay, here's our scenario on number 14. We have a radius of 7 kilometers and we have a central angle of 2 pi over 3. Now this time, that is given to us in radians, so we don't have to convert. We're just ready to plug it into the formula. So, 1/2 times, all right, our theta is 2 pi over 3, and our radius is 7 squared. We'll just go ahead and write 49 to make things easier. All right, going through here and doing all your math, that is going to get you 551.3 kilometers squared. Okay? Okay, for number 15, we have an angle measure of 19 pi over 12, which is already in radians, so we don't have to convert. And then we have a radius of 23.6. So if I use my formula, area is 1/2 times, all right, my theta is 19 pi over 12. My radius is 23.6 squared, okay? Very carefully entering that into the calculator and clicking the button to reduce it to a decimal, I'm going to get 1385.2, and this is in miles squared, okay? Or meters squared, actually. I think this is meters. Okay? Okay, so for number 16, they tell us that the area of the sector of a sector of a circle that has a central angle of 240 degrees, the area is 134, and they want us to find the radius. Now this one's a little bit different because usually they're giving you the angle and the radius and you're finding area. So let's work through it. We're just going to fill in different things. You're going to be filling in for area and finding radius instead of filling in for radius, finding area. But still in all, we have this in degree measure, so the first thing we need to do is convert that to what? Radians. So multiply times pi over 180, and that is going to get you 4/3 pi, or 4 pi over 3. So now we're ready to fill into our formula. Our area is 134. That's going to be equal to 1/2 times, all right, theta we just found as 4/3 pi, or 4 pi over 3, and then r squared. So when you do the math on all of this part, and let me go ahead and walk through it. So naturally the 1/2 and the 4 cancel out and leave you 2. So what you have is 2 pi over 3, or 2/3 pi times r squared. When you multiply by the reciprocal of 2 pi over 3 times both sides, you're going to wind up with r squared is equal to, let's see, it was 63.9 something. We're going to round off, so we're not going to be worried about that specifically. Now, I don't want r squared, I want r. So I'm going to take the square root of each side. And r is equal to, if I round this off to 64, the square root of that is 8. And we are dealing with feet. Now, why didn't I use the plus or minus sign? Because usually when we take the square root of both sides, we put the plus or minus. Well, we're looking for a radius length, and there's no way to have a negative length in measurement. So anytime you are trying to find a measurement, when you have this, when you use the square root property, you don't have to use the negative part, okay? Okay, let's look at number 17. We have a windshield wiper blade scenario going on here. And the windshield wiper arm is 32 inches long, and it sweeps through an angle here of 125 degrees. And I want to know what is the area that just the arm sweeps, okay? So I'm going to have to find two different areas and subtract. I'm going to find the whole area, and then I'm going to subtract just this part under here. Well, if the arm is 32 inches long and it's sweeping all that, and this part of it is 21 inches, what does that leave for this part of it down here? Well, that's going to be 11 inches. So I'm going to find the area, or number 1 arm area, and then number 2 is where the arm is only 11 inches. And your arm is actually what? That's going to be your radius. That's what relates to your radius. So the first thing is I have my angle in degrees, so I'm going to multiply 125 degrees by pi over 180 so that I can convert that to radians, and that's going to give me 25 pi over 36. Okay, so first let's find the area of the 32-inch arm. So that's going to be 1/2 times the radians that I just found for my angle, and that's 25 pi over 36, and that's going to be times my radius squared. Since this is the 32-inch arm, it's going to be 32 inches squared. And when you do all the math on that, and I would use a calculator if I were you, I did, you're going to get 1,117 inches squared. Okay? Now we need to find the area of the 11-inch radius. So we're just going to do the same thing. 1/2 times 25 pi over 36 times, this time, it'll be 11 squared. And when you punch all this into your calculator, that is going to get you 132 inches squared. So now we're going to subtract those two, and that will leave you with 985 inches squared. That is the actual area that just the blade covers. Okay, good job.